Okay, now a 2000 turn solenoid, okay, of length 40 cm and resistance 16 ohm is connected to 20-volt supply. Find the magnetic flux density at the end of the axis of the solenoid. Okay, well, what it asks for, what the question asks for magnetic flux density. Again, I said magnetic flux density is the same as magnetic field strength or magnetic field intensity. So it wants the B. It wants the B. Okay, so at where? At the end of axis, not at the middle, at the end. So the formula must have half. Because at the end. At the end. So, yeah. So half mu naught and I. So what is solenoid? Again, solenoid is remember solenoid. Okay, so hold on a second. Solenoid is this one. Yeah, it's not a circular loop. It's not circular loop with multiple turns, but it has length. It has length. Solenoid must have length. It must have length. It must have length. Solenoid must have length. So the formula is mu naught and I for the middle, but for the end is half mu naught and I. Okay. Yeah, for solenoid it must have length. For circular coil, it doesn't have length. And it also provides us resistance, voltage, multiple turns. This n turns. So okay, so these are the values. I rewrite it down. The 40 cm I change to meter as a unit. Okay, and then now for the formula I need current. Do you see I need current? But I don't have current, so but it gives us the resistance and voltage. So from here, V equal to IR, we can find the current. Okay, let's calculate. So 20 volt, okay, 20 volt equal to I. Resistance is 16 ohm, yeah, 16 ohms. So I got my current 1.25 ampere. That's the current. Okay, that's the current. Now, the next one. Let's look. Yeah, next one. Let's look. So I got the current already. And then the end. Yeah. In fact, the end over here. The end over here is the small n. The small n over here is total turns divided by total length. Total turns divided by total length. I already have the total turns, 2000, and the total length. So I can find the small n is the number of turns per unit length. I just substitute inside lah. I just substitute inside here. Yeah, and then I got this. I got this formula. And then for the n, we use half. Yeah, half mu naught and I. Okay, so I just substitute all the values inside, and that's the answer. Okay. Okay. So half mu naught is 4 pi exponent negative 7. This value you can find in the list of constant. Yeah, it will be provided in the exam, list of constant. And then total turns 2000. And then current I got 1.25 just now. 1.25. So the total length is 0.4. So what's the answer? Yeah. So I got the answer 3.927 exponent negative 3 Tesla. That's the magnetic flux density. Sometimes magnetic flux density also use the other unit. You can also write as or you can also rewrite the unit as Weber per meter square. Because this one is flux density. It related to the chapter electromagnetic induction. When you study about magnetic flux, then you study about Weber. Yeah, because it related to this formula. Flux equal to BA cos theta, which you learn in the chapter 5, electromagnetic induction. So here also we have the magnetic field strength. So from here, B equal to flux over area cos theta. So that's why you have this unit Weber. Flux is Weber. and area is meter square. So end up you get Weber per meter square. That's the unit for Tesla also. Okay, so magnetic field has 2 unit, Tesla or Weber per meter square. So for this, that's why this is called magnetic flux density. Magnetic flux density, yeah, because it's flux divided by area. Flux divided by area, that's why it called density. Flux density. Okay, this is the same thing as field strength. This is the same thing as field strength. Yeah, flux density, field strength, field intensity, all they refer to the same thing, magnetic field strength, which is B. B. So B has 2 units, Tesla or Weber per meter square. Okay, so that's the answer. Okay, is it correct? Yes, it is correct. Yeah, almost equal. Okay, so see you in the next videos.